Hi NET NAT aspirants, we have taken the first year topic determinants. Determinants. In these questions, we have to solve these by using properties. By using properties. If we are going to evaluate, then it is time consuming and we are out of the examination, especially MCQ type examination. So, our first question is 1AB. 1xb the second row, 1cx the third row. If the determinant is 0, we are asked to solve. Solve for x. Solve for x. We are interested in the value of x. We are interested in the value of x. First, orthodox method by using row operation. By using row operation, as there is column 1 1, as here is column 1 1, subtract first from row second row 1, subtract row 1 from row 2 as well as row 3, subtract row 1 from R2 as well as R3. We need 0 here, we need 0 here. We are trying to convert this determinant in a row echelon form. In row echelon form, diagonal 1, the beneath entries, the lower entries must be 0, must be 0. Here column is 1 1. Switch over to this strategy, R2 minus R1, R3 minus R1. It will give here 0 0. Let me solve for you. Rough work. R2, what is mine R2? That is 1xb. R1, we have 1ab. Subset, we have 0, it's x minus a, and it's 0. We have to write this thing instead of R. To similarly perform this row operation, R3 1cx, R1 is 1ab, subtracting, we are going to have something 0, c minus a, x minus b, and we have to accommodate this instead of R3. So keeping R1 intact, instead of R2, we can write O x minus a is 0. That's the second row. Third row is 0, c minus a, and x minus b. Now look at this. Here 1 0, this first row and first column has been deleted owing to the properties of determinant. First row, first column deleted. We have x minus 0, x minus a is 0, c minus a, and x minus b. Expand this determinant. Expand this determinant, x minus a times x minus b, and that is negative 0 times c minus a is equal to 0. It is no more. We are left with two brackets, x minus a times x minus b. From first either x minus a is equal to 0, so we have x is equal to a, and from this x minus b is equal to 0, we have x is equal to b. So the values of x are a and b, a and b. One can one cannot feel surprised. One cannot feel surprised. You can attempt this without solving anything. Without solving it. Look at this x. If we expand this, we are going to get any expression of x as linear, So try this option, as it has power 1. If I write instead of this x, a, instead of this x, I write, a. Then look at this, 1AB, column row 2 and row 3 are identical. If instead of this x, I can plug in the value x, plug in the value of x as a, value of x as a from the options or from here. We have 1AB. Two rows are identical, then value of determinant is 0. We have verified number 1 values. Second option is, we have here x. Second option is b. Instead of x, I can utilize b here. Look at this. If I write b here, look at this. This column is 1 1, third row is bb, and this column is 1 1. If I take b common from here, here remains 1 1 1. If I take b common from column 3, what remains? 1 1 1. column 1 and column 3 are identical, column 1 and column 3 are identical, column 1 and column 3 are identical. So the value of determinant by virtue of the property of determinant is 0. So in that case, we have verified. We have utilized the options direct here. Look, if I can write A here, A. Now look at this. Two rows are identical, value of determinant is 0. Instead of this X, I can write B. Now look at this, column 3 and column. If I take B common from here, if I take B common from here, here remains 1, 1, 1. Column 1 and column 3 are identical. The value of the determinant is 0. That's my tiny effort to solve by row operation. It's up to you. Or manipulate the options, and arrive at a solid platform. Moving toward the next question.